Now, the third case for sensitivity analysis is changes in the resources. This means changes in the right-hand side of the equation. The right-hand side values of the constraints often represent resources available to the firm. The resources could be labor hours or machine time or perhaps money or production materials available. In the high note sound company example, the two resources are available: hours of electrician's time and hours of audio technician's time. If additional hours were available, a higher total profit could be realized. How much should the company be willing to pay for additional hours? Is it profitable to have some electricians work overtime? Should we be willing to pay for more audio technician time? Sensitivity analysis about these resources will help us answer these questions. Note that when changes in the resources happen, it will change the feasible region unless the constraint is redundant. However, the amount of possible increase in the right-hand side is limited. If the right-hand side is increased beyond the upper bound, then the objective function would no longer increase by the dual price. There would be excess resources, or the objective function may change by an amount different from the dual price. The dual price is the improvement in the objective function value that result from a 1 unit increase in the right-hand side of the constraint. The dual price is relevant only within limits. Here's a graphical explanation of a sensitivity analysis when changes in the resources occur. If the right-hand side of a constraint is changed, the feasible region will change, and often the optimal solution will change as well. In the high note sound company example, there were 80 hours of electrician's time available each week, and the maximum possible profit was $2,400 at this point, right? There is no slack for this constraint, so it is a binding constraint. If the available electrician's hours are increased to 100 hours, um, like this, then the new optimal solution um, uh, is is 0.25 rather than 0.20. Now the electrician's resources increase from here to 25, and therefore it changed the feasible region, and we know that A is the solution, and it gives us more profit than before because of that. So if you calculate uh, the profit, before it was $2,400 in profit. Now it is $3,000 of profit. So there's a difference of $600. Or you increase 20 to 25 and you earned $600. So if you divide it by that, then you can see um, the resource increased from 80 to 100 hours, so 20 hours of increase in electrician's time, and you can divide 600 by 20, and it gives you $30 per hour, right? So you can make $30 per hour. So as long as the cost is not that high, then you can proceed with increasing the electrician's hours. If the hours were decreased to 60 hours, right? So then it was 80 hours before. Now it is 60 hours. So you decrease it by 20 hours. And what happens at the time? At the time, the it goes down there, and then the feasible region decreases, right? And if you calculate everything, then you will see that the optimal solution is 0.15. This is the point. And at the time, the profit is $1,800. Since reduce 20 uh, electrician's hours, you find that a decrease of profit $600 happened, and you divide it by 20 and $30 per hour, right? So you see $30 you are gonna make less than before by decreasing electrician's hours. So this $30 per hour change in profit that resulted from a change in the hours available in electrician is called the dual price or dual value. The dual price for a constraint is the improvement in the objective function value that results from a 1 unit increase in the right-hand side of the constraint. The dual price of $30 per hour of electrician time tells us we can increase profit by that dual price $30 or decrease the profit by the dual price of $30. However, there is a limit to this as there is a limited audio technician time. If the total hours of electrician time were 240 hours, the optimal solution would be 0.60. So if you increase it from 80 to 240, then it goes from 20 to 60. It goes up like that. Um, However, if you increase it beyond 240, then this increase will no longer be able to produce more profits. It's limited up to 60 because it's constrained by the second constraint, the technician's hours constraint. You cannot just increase electrician's hours only. You have to increase both electrician's hours and technician's hours to change your optimal setting. So there's a limit for your increase. You cannot just unlimitedly increase electrician's hours. So we talked about in this lecture linear programming. There are properties and assumptions of linear programming. Linearity is the most important thing that we considered there. And the second topic was 5 steps for linear programming problem. First of all, we have to understand the problem and set the objective function. Afterward, we have to identify the constraints of the problem, and we have to put them into graphics. We have to draw the constraints and then see where the feasible region is and find the solution using ISO profit line or ISO cost line. That's what we learned in 5 steps of linear programming problem formulation. And was very much related to graphical solution of linear programming. And lastly, we learned sensitivity analysis. Sensitivity analysis is very important because we are asking many what if questions, and those questions can be answered using sensitivity analysis. And there are 3 types in sensitivity analysis. First was of changes in objective function and changes in technological coefficients and changes in the resources, right? So those 3 things we have learned, and these are all very fundamental concepts for us to learn and advance our learning in this topic. So I hope you understood this chapter well. Thank you.